Hello, everyone. Today's lesson is on Chapter 6, Section 4, and we are going to be working on comparing linear and nonlinear functions. Comparing linear and nonlinear functions. Let's get started. All right, folks, today's daily objective is I can identify linear and nonlinear functions from tables or graphs. I can compare linear and nonlinear functions. So we are working from page 268. 268. It's not really a key idea here, but there is a nice sentence I pulled from the book or a paragraph. It says the graph of a linear function shows a constant rate of change. Okay, so basically a graph of a linear function shows a constant slope. A nonlinear function does not have a constant slope rate of change. Okay, so its graph is not aligned. So if you can find that slope and if it's constant, rate of change is constant, it's considered a line. Let's take a look at example 1. Again, I'm on page 268 if you're following along. We have two questions here. Does the table represent a linear or nonlinear function? And it says to explain. All right, so basically this first one, if you look at our table, we have the first row, we have X. The second row, we have Y. As X is increasing by 3 each time, you can see that Y is decreasing by 8 each time. So if you were to determine whether or not this is linear without graphing, you can say that it is linear. And the reason why it's linear, it is because it has a constant rate of change. It has a constant rate of change. So as X increases by 3, Y decreases by 8. So the answer is linear. Letter B, X, 1, 3, 5, 7. Y, 2 to 11, 11 to 33, 33 to 88. Now, when you're given these questions, it's kind of tempting to see that we have a pattern, and sometimes you see a pattern develop and you start to think, well, that's got to be a linear situation. Okay, but the pattern isn't consistent. So it goes up 9. So it goes up 2 on the X, which is really good. But then if you examine the Y, it goes up 9, up 22, up 55. It's not constant. So this would be considered non-linear for letter B, non-linear. And the reason there is that the rate of change is not constant. So the function is not linear. The rate of change is not constant. Okay, so that would be you are given a table and you're asked if it's linear or not. And if it's got that constant slope or constant rate of change, you can conclude that it is a linear situation. So keep a lookout for those types of questions coming up. Example 2, here we go. Now we're going to be given graphs and says, does the graph represent a linear or nonlinear function? These go pretty quickly. You actually have the graph right in front of you here, and you can see this little swoop, and it kind of swoops up, and then it flattens out, then it swoops back up. And if you see something like this, you might be tempted to think, well, that's kind of a line, but it's not. This is nonlinear. Non-linear. Okay, it changes and it goes up, but it's not at a constant rate of change. So the answer in this case, the graph is not non-linear, and the reason behind it, it's not a line. Okay, not a line. All right, letter B. As you can see, this is a graph that is y equals -2, okay? And you've got it is a straight line. In this case, would be linear, okay? And the reason behind that, the graph is a line, so the function is linear. That brings us to the first three on your own. So two tables and one graph, numbers 1, 2, and 3 on page 268. Let's try those at this point. Page 268, numbers 1, 2, and 3. All right, so when you look at these tables here, first off, you're going to go from 0 to 7, you got +7. 7 to 14, you got +7. 14 to 21, you have +7. That looks great. Now let's take a look at on the y side of things. 25 to 20 is -5. 20 to 15 is -5. 15 to 10 is also -5. So now you're asking the question, is it linear or not? This is a constant rate of change. If you had to find the slope, you would have the slope would be -5 over +7. That's not part of the answer, but if you did have to see that, it would be -5 over 7. And this would be considered linear. Linear for number 1 on your own. So as x increases by 7, y decreases by 5. Number 2. 2 goes to 4 by adding 2. 4 goes to 6 by adding 2. 6 goes to 8 by adding 2. That looks awesome. Okay. 8 goes to 4 by subtracting 4. 4 goes to 0 by subtracting 4. 0 goes to -4 by subtracting 4. So again, in this case, you have a constant rate of change. So as x increases by 2, y decreases by 4. So this is considered linear. Number 3 is a graph. And since we can look at the graph and see, you're tempted to put linear because you've got these lines, but it's not constant and it's not a straight line. Okay, it goes up and then it takes a turn, it comes back down. So this is considered nonlinear. But I've had students in the past try to create this argument that, well, it is linear because this section right here is a line. Well, you've got to look at the entire graph. Okay, so in that case, it's nonlinear. The graph is not a line. All right, that brings us forward to example number 3. All right, in an example number 3, the question is, which equation represents a nonlinear function? Okay, so I think I kind of mentioned this last week. We talked about this being an MCA type of question. You'll be given 4 equations and they ask you which one is nonlinear. Okay, so we're looking for an equation out of these 4 that does not look like slope-intercept. Basically, if it doesn't look like slope-intercept, okay, mx plus b, if it doesn't look like mx plus b, it is considered nonlinear. Okay, so that's what this nonlinear is going to be all about. If it doesn't look like mx plus b, we are going to consider that nonlinear. All right, so if you look at these, letter A is a straight line at y is equal to 4.7. So this is just a line. Any x, your y is going to be 4.7. So that doesn't qualify. I'm going to skip C for now and go to B and D. B, you've got the slope of pi times x and pi times x. So in this case, your B and B would be 0. So this is also a line. Letter D on the same fashion is y is equal to, and if you worked out this distributed property, would have 4x minus 4. And with that in mind, you can easily see that that is also a slope-intercept line. So lastly, it brings us to letter C, y is equal to 4 over x, okay? So what this is that you cannot rewrite this. You cannot rewrite it into slope-intercept. So this is considered nonlinear. Nonlinear. So you're dividing by x, and you cannot rewrite it so that we have a slope and an intercept. So in this case, this would be considered nonlinear. So you can't rewrite it. And so the other ones are linear, and y is equal to 4 over x is a nonlinear function. And that's example 3. All right, last example for the lesson is example 4. It's a word problem. And I have taken the graph out of the books to help speed things along here with regards to this. But it says account A earns simple interest. Account B earns compound interest. So if you have ever had a class on simple interest, basically account balance, your chart, you most of the time you get interest on a monthly or a yearly basis, let's say, and you're only getting interest on the account, what the initial account. So the $100 you put in the account, okay? Now, compounded interest is basically interest that builds upon the initial deposit plus any interest that's gained, okay? So the table shows the balances after 5 years. Graph the data and compare the graphs. So you can see the graph here is account A, which would be this bottom graph, goes up first year 110, second year 120, third year 130, fourth year 140, and fifth year 150. Account B's got a little bit of a swoop to it, and it sits above account A's line. And after 0 years, the initial account is at $100. 1 year, 110, 2 years, 121. See where that compound interest comes in. You earn a little bit more interest because you're not just getting it upon the initial deposit, you're receiving the interest on the deposit plus interest earned. So it really starts to grow. After 5 years, you're up over $11 more for that account, that deposit of $100. So in this case, both graphs have initial balance that are the same, and they're positive increasing graphs. And the balance of account A has a constant rate. So this is considered a line. It's constant, okay? Account B is non-line. It's a non-linear. As you can see, it doesn't rise constantly. It rises at a different rate each year, okay? So the balance of account B increases different amounts each year, and the rate of change is not constant. And the account B is non-linear. And that would be example 4 under real life application. All right, to finish this lesson, it's pretty quick. We're going to do numbers 4, 5, and 6 on page 269, which is on your own, number 4, 5, and 6. And what it says is this: does the equation represent linear or nonlinear functions? Okay, so does the equation represent a linear or nonlinear function? So we're looking for slope-intercept, all right? So if it's slope-intercept, we can consider it linear. We're looking for a constant rate, and we're looking for an intercept. All right, so this first one, it's like a blinking light. It's right out there. If this is slope-intercept, you got y is equal to 1, it's just the slope, times x plus 5 is the intercept. So the answer there is linear. L-I-N-E-A-R. Number 5, y equals 4/3 x. In this case, again, you've got a y equals a slope 4/3 times x, and our b in this case is 0. Okay, it's 0 here. So again, this is also linear. Linear. Even though there's a fraction there, it still is linear. So you can rewrite the equation in both of these in slope-intercept form. Well, this one's already in slope-intercept form. And the last one here is we kind of talked about this last week. When you're given this question, you see these like this squaring or cubing. You'll get these. So it's tempting to kind of think, well, that looks like a straightforward equation. It's got to be linear, but it is non-linear. If you actually graph that out, it'd be a parabola. It is non-linear. You cannot rewrite the equation in slope-intercept form, and that would be number 6 on your own on page 269. So that's the lesson today on comparing on 6.4. And we are comparing linear and non-linear functions. And so you're going to be asked to distinguish what's linear, what's non-linear by a table, by a graph, and by an equation, okay, like these last few that we just did. So you're going to be asked to determine that from that information. So they're kind of fun questions to do. Hope you found this beneficial. And we will talk with you soon. Take care, everyone.